Hey guys, I'm going to get straight into the derivation of kinematic equations. So this is probably the first thing you're going to see when taking a physics class, and I know a lot of students like to look at problems, kinematic problems, kind of identify what variables are there, what are not there, and then try to correspond that to a formula sheet. I don't think that's the most efficient way to approach these problems. I think it's better if you just do as many practice problems as you can and really don't look at the formula sheet, just try to understand how to derive these equations, try to understand where they come from, and hopefully it becomes more instinctual rather than having to look back and forth at a formula sheet. So with that being said, let's get into it. So the four kinematic equations are final velocity equals initial velocity plus acceleration times time. Second is final velocity squared is equal to initial velocity squared plus 2 times the acceleration times displacement. The third kinematic equation is the displacement is equal to 1/2 times final velocity plus initial velocity times time. And our last equation is delta x is equal to initial velocity times time plus 1/2 at squared. So the first one I want to look at here is this one. It's pretty simple. So I want to start out by actually giving you two quantities that you should keep in mind while we're going about these derivations. The first one is average velocity is equal to the change in position or displacement over the change in time. The average acceleration should be equal to the change in velocity over the change in time. So keep these in mind while we're going about our derivations here. So with that being said, the first one, we're going to start out with this equation right here. Again, the average velocity is equal to the change in position over the change in time. Now, if we just multiply both sides by time here, we are going to get average velocity times the change in time is equal to, and these should cancel out, and we just have displacement. If you're not clear on the difference between distance and displacement, I encourage you to review that on your own. It shouldn't take too long. It's a pretty simple distinction. So now that we have solved this, realize that you can rewrite delta x as the final position minus the initial position over the final time minus the initial time, right? So with that in mind, we can rewrite this as the average velocity times time is equal to the change in position, so x final minus x initial. This can also be rewritten as x initial, or sorry, as x naught, right? The 0 down here, it's a naught, and these mean the same thing. It's just different ways of writing them. They're interchangeable. So hopefully that doesn't confuse you as I write these down. So let's see here. Where were we? Right. So we have average velocity right here, and you can rewrite average velocity as 1/2 final velocity plus initial velocity. And if that doesn't really make sense, just think about how you go about calculating averages in general. So you're just going to take the number of quantities you have, add them together, and divide them by the amount of quantities you have, and that gives you an average. And it's the same concept here, right? So we have a final velocity and initial velocity. If we just add them together, divide by 2, we're going to get the average velocity. So now we pretty much have everything. All we just have to do is put it together, right? So we can start with delta x, which we got from right here, and that's going to equal the average velocity, which is 1/2 v final plus v initial times t, and we get the delta t from here. So all we're really doing is taking the same equation right here and just replacing this v average with an equivalent expression, right? And this is the same as this right here. So there, one down. Let's keep going. So the next one I want to do is, let's see, let's do this one. V final equals v initial plus acceleration times time. So for this one, let's start with the expression we know that the average acceleration is equal to the change in velocity over the change in time. So I'm just going to copy that real quick down here. All right. So we're going to start with that. And similar to what we did earlier, we can rewrite this expression as final velocity minus initial velocity over the change in time, so time final minus time initial, right? And to rewrite that again, let's just keep the time as delta t on the bottom, and we're going to keep this. So v final minus v initial. So we can rewrite this to make it a little clearer. The average acceleration is equal to v final minus v initial over delta t, right? And that's just the same thing that we wrote up here. Just want to rewrite it to make it a little clearer, away from all the clutter. So there we go. So if we want to rewrite that, let us multiply both sides by time. If we do that, similar to earlier, these cancel out, and you're left with change in time is equal to average acceleration. I'm sorry, change in time times average acceleration is equal to v final minus v initial. This should start to look familiar if we just add initial velocity to both sides. We are going to get that v final is equal to v initial plus at. And that's our final equation. As you can see, it is this one right here. All right, 2 down. The next one I want to do is this one. The displacement is equal to initial velocity times time plus 1/2 at squared. So let us start with, let's see here, the equation. Let's start down here. V final is equal to V initial plus AT. I'm just going to put that up here. That's what we just solved right here, right? And I'm going to put up here for reference. So again, going back to average velocity, we know that average velocity is equal to V final plus V initial over 2. So we have this expression right here, and we have an expression for final velocity. So what we should do is plug it in here. Plug in. And what you're going to get is that the average velocity is equal to initial velocity plus acceleration times time plus initial velocity over 2, right? And if we were to combine like terms, we're going to get that 2 times the initial velocity plus acceleration times time over 2 is equal to the average velocity, right? If we were just to simplify that a little bit and actually carry this expression out, or change the expression, we get that the average velocity is equal to v initial plus 1/2 at. starting to look familiar, the last thing we would need to do is probably multiply time somehow, right? And we know that average velocity is equal to the change in displacement divided by the change in time, right? It's the same expression, or same equation. I'm just rewriting average velocity going back to this expression that we already know, right? So now it's pretty clear. We're just going to multiply both sides by the change in time. And you're going to get that the displacement is equal to v initial t plus 1/2 at squared. And that is your third kinematic equation. And that's this one right here. So now we have one more left. It's going to be v final squared is equal to v initial squared plus 2a delta x. So if you notice, this is the only kinematic equation that we have that doesn't have time in it, right? So going back to basic algebra, the way that you would eliminate time is to find something, an expression that equals time, right? That contains other variables that we have, and plug it in somehow. So similarly to this equation right here, or how we derive this, I'm going to start out with the same quantity, or the same expression. Average velocity is equal to, it's very late right now. Average acceleration is equal to the change in velocity over the change in time, right? If we were to isolate time, right? And the reason we want to isolate time is because we're trying to get that equivalent expression, right? So to isolate time, we can multiply both sides by time, right? And we get average acceleration times time is equal to the change in velocity. Then we're just going to divide average acceleration, both sides by average acceleration, right? These are going to cancel out, and we're going to have that the change in time is equal to delta v over average acceleration, right? So that's going to be the expression we use to substitute time, and we can really do that in any of the previous equations that we already know. So going forward, I want to keep three things in mind here. The first is that displacement is equal to average velocity times the change in time, right? And this is just me rearranging, going back to the beginning here, this equation, right? All I did is multiply both sides by time. And I got this equation right here. Second thing I want to keep in mind is that the average velocity is equal to v final plus v initial over 2. Last thing I want to keep in mind is that time is equal to delta v over a, right? And that's that is what we solved right here, right? That's the last thing we solved. Keeping all these in mind, we can take this quantity, right, and substitute this in for this. And we can substitute this in for this and see what we get. That would eliminate time, which is what our goal is here. So we have displacement is equal to v final plus v initial over 2 times delta v over a. We know that delta v can be rewritten as v final minus v initial, right? So let's just rewrite the whole thing. displacement is equal to V final plus V initial over 2 times V final minus V initial over acceleration. And using FOIL on the top here, we get that V final squared minus V initial squared over 2a is equal to the displacement. And I just multiplied the top and the bottom, top using FOIL, and the bottom using standard multiplication. So the next thing I'm going to do is, I think it's pretty clear, right? We're going to multiply both sides by 2a. Now it should start to look pretty familiar. So again, these cancel out, and we get 2a delta x is equal to v final squared minus v initial squared. If we were to rearrange that, just switching the sides here, make that more clear. V final squared minus v initial squared is equal to 2a delta x. Add v initial squared to both sides, and you're going to get our final formula, which is v final squared is equal to v initial squared plus 2a delta x. And as you can see, that is our final formula. So thank you guys for watching. If that was informative in any way, please like and subscribe for future physics videos and any other STEM classes that I'm going to start making videos for during this quarantine, because it's fun and I want to help you guys out. If you guys have any ideas for any other topics I could cover, whatever it is, please just comment that below, and if I feel like I'm able to, I'll definitely try to get to that. Thanks guys for watching.